In this Grasshopper tutorial, I want to show you how you can produce this parametric pattern. As you can see, I can change these sliders and produce different results. And we will also talk about the parameters which will produce this pattern. And as you can see, we can also model this in 3D, and I'm going to make this as a dome, so we can simply define the height. So let me just put this at the front. So we can change the radius, and basically we can change this and produce the pattern. And we can also change the numbers of the pattern. And at the end, I'm going to explain how we can produce a surface from this, and you can download this definition from the website. So at the end, we will produce a surface based on those curves, as you can see here, and we can have the surface and the windows, as you can see here, and we can also convert this surface into a solid by using the offset surface tool. So basically this Grasshopper tutorial will teach you how to model this parametric pattern, and you can see how I can make this in 3D, and we can see this in the artistic mode. So this Grasshopper tutorial will just model this pattern. Okay, first of all, you can download this definition from the from our website, parametrichouse.com, and I'm going to explain this from scratch. So what I'm going to do is to start with circles, and basically this is a simple algorithm. So what I'm going to do is to first of all define 3 or 4 circles based on what you want to do, and then I'm going to divide these circles into points, and as you can see, we can divide this into points and so on. After dividing this, we can rotate the circle, and by rotating the circle, the points will also rotate, and when we connect these points together, we will have some pattern. So this is the first explanation of this, but let's do this in Grasshopper. So we can go to the curve section and choose a circle here, and let me put the bifocals plugin so you can see the components. Okay, so circle is a simple component and it produces a circle in Grasshopper. So we can give this circle 3 different radiuses. So I'm going to go to the params menu, and instead of using a number slider, I'm going to use a gene pool, and because this will help you to increase your number of the circles easily by just adding this gene count. So this is the number of sliders we need. So maybe we need 4 circles, and this is the minimum and the maximum of the number sliders. So this is the minimum. Let's just put this to 10 and 100. So if I give this to the radius, you can see that this is the radius of the first circle, the second, the third, and the last one. So what we want to do is to give these circles a little bit of a height. So what we can do is to move these circles, or just do something more professional. We can go to the vector section and use the construct point and give this to the plane. Basically, a plane uses a plane to define the circle, but if you connect a point to a plane, what happens? Always remember that if you connect a point to a plane, it means that you are defining an XY plane. So we can simply connect this point to the plane without defining an XY plane, and that is what exactly we are saying to Grasshopper. We are saying that we want an XY plane and put those circles in the XY plane. So I can just give this point to the plane, and the most important thing about not moving the circles is that you can put this algorithm simply and make it smaller and work efficiently. So I'm going to give this gene pool copy, Control-C, Control-V, and copy this to the Z. And this is how we can control. Okay, let's just give this from 0 to 100, or maybe more. And this can be the first circle, let's go back, and the second one, the third, and the last one. So you can also define the radius, as you can see here. Let's increase this radius to 200. Okay, so this is the radius and this is the height of the circle. So you can see how simple it is to produce that. After that, we can divide these circles into points. So I'm going to type divide, and let's just put this division to that. We can maybe define a 15 or 16 division. Okay, and we can increase or decrease the number of the division here. Is simple, but what we want to do is to connect these points together. Okay, assume that we want to simply connect these points, this point to this point to this point and up to there. So assume that we want to produce a simple curve, something like this. It's a loft procedure, but we can do this with a simple data management. So what I'm going to do is to go to the curve and use an interpolation. And what will happen if I connect an interpolation to the point? You can see that this is not producing the curves. And that is because if we put the cursor on the points, there are 4 groups in 21 numbers. So this is the first group, second group, third group, and the last group. Okay, we can call this 0 brackets and 1 and 2 and 3. And the numbers are something like this. This is the 0, 1, 2, 3, so on, 0, 1, 2, 3, 0, 1, 2, 3. And so when we connect these points to the vertices for interpolation, the operations are going to be in groups. So it goes to the first group and it sees the data, so it's 0, 1, 2, 3, 4, so it's going to connect those again together. So the output will be a circle. Again, to the next group, it's going to connect all of these together, and the third one, and the last one. So what we can do here is to define something else. We want groups something like this. This should be the first group, and this one the first, the second, the third, and the last data. So when we say we want this to interpolate this, it can connect this like that. So if you just zoom in, you can see that there are 4 groups in 21. So we want 21 groups in 4 items. What we can do is simply use a flip matrix here, and it's a simple tool. So I'm going to give this a flip matrix, and here you go. You can see that it's going to be 21 groups in 4 points. So you can basically convert those groups into the number of the n you can see here. So let's just connect. Here we can go to the params menu and connect a param viewer. This is before the flip matrix, and you can also take those zeros out by right-clicking and using the simplify. So let's just do this. Okay, this was before the flip matrix, and this is after the flip matrix. You can see that there are 4 branches, 1, 2, 3, 4, 21 points. And now it's going to be 21 groups, 21 branches into 4. You can double click on this and you can see how the data has been converted from 4 branches and 21 items into 21 branches and 4 items. So remember that you can simply do this with a flip matrix, and let's just turn everything off, and you can see how simple we can define this and change the location. Okay, but the most important thing before connecting these points is to let's assume that we rotate these circles before we divide them. And always when we bake these circles in Rhino, and let me just select them, and let's go to the analyze direction here. You can see that there are these points which are the curves seen. these are called the curve seam. And when we rotate a curve, so assume that I just choose this and rotate this a little bit, okay, you can see that this seam has to be rotated. So when we just put a division, the division will start from here. So this is a simple thing you can do before we divide this. So let's just rotate 3D these circles, and I'm going to the center of these circles can be simply those points. These are the center of rotation. The axis is Z, and that's fine. You can just have this, but let's assume that it's a Z direction. And for the angle, we can right click and use degrees, because Grasshopper uses the radians, so I'm going to use this degree one. And again, we need 4 different rotation from maybe 0 to, you can give whatever you want, 90 degrees. Okay, so let's give this to the rotation. You can see that we can rotate, and there's not anything we can mention, but it's rotating on itself. And now we can give this to the division. Okay, so you can see that I can rotate the first set of points, the second, the third one, and the last one. Okay, so this is how simple we can produce those curves. And what we need here is to mirror these curves. So I'm going to use this mirror, and as you can see, the default is a YZ mirror plane. You can also give it an XZ, doesn't really matter because it is a radial pattern. So you can see how this performs. Okay, we can make this like something like this, change the radius. Okay, you can see how simple we can design. Maybe you want a tree, so I'm going to increase the height and decrease the radius, and also change the numbers, and also work on the rotation. Let's just put this to 0 and just play with these numbers. Okay, so you can see that from the top there's a pattern also like that. So let's change the radius from small to bigger. This is going to be a good one for 2D patterns. We can also put everything to 0 and produce a simple 2D pattern. So let's just put this at top. Let's go to rotation, and you can see how beautiful it is. And you can produce these patterns. Okay, and we can put this to 90 degrees or something like that. The last degree, you can see there is a place where these reach each other, and that is because the number of the division. So if I put this to 10 of that, the circle is going to be divided into 10 different sections. Okay, so this is going to be something like 360 degree divided by 10, so it's going to be 36 degree. So what I can do is to simply, if I want to define this, I can delete this, and let's just assume a 360 degree and divide this with this number. We have to have an even number, because if it's odd you can't have a complete number. Okay, 36 degrees. Let's just put this back up here, and then now we can multiply this with the gene pool. Instead of giving a number like 0 to 90 degrees, we can say 0 to maybe 10 times the 36 degrees. So this is going to be multiplied by this division and then given to the angle. So we can define this maybe 0. Okay, we have to put this into 0 decimals. So 0, 1, 2, and 3. Okay, this is a simple one, and you can see that the end and the start is just reached from at the, they are reaching each other at the mirror section, and you can just change these numbers and always have a complete pattern Okay, and let's just give this a little bit of a height. So I'm going to bring this up. Maybe we need a simple dome. Okay, and we can change this. We can also change this number and play with those numbers. Okay, 1, 2, 3, maybe some simple pattern. Okay, so at the end, I'm going to talk about how we can produce a surface from these curves. So let's go ahead, and we have this curve, we have the mirror. We want to produce a surface from this, so I'm going to use a loft and put this curve to the loft. And you can see nothing happens. That is because we have 16 groups into one data. So it comes to the first group, it wants to loft, nothing happens, goes to the second, wants to loft. So I'm going to explain these in the Grasshopper course, because this week I'm going to explain about flatten graph, simplify, partition, and many more. So I'm going to flatten this, and you can see that the surface is going to being produced, but you have to go to the options, the loft option, and choose the closed, because we want the first and the end to connect. Okay, so you can see that we have the surface here, and now we can simply use the intersection, physical, and the surface split to split the surface. So I'm going to split this surface with two sets of curves, this curve and these curves. Okay, let's connect these curves to that. And if I first connect the first set of curves, if I make the split, you can see that it's going to, let's just bring this here, it's going to just split this into surfaces like that. And let's just give this another mirror here. Okay, so I'm going to give all of those curves, and what happens is that it's going to be into fragments. So here we are, and at the end we can simply give a curve to this and extract. Let's just turn everything off. Okay, these curves are simply the borders of that fragments. I'm going to scale them and then loft them together. So let's scale this curves. We need the center, so we can simply extract the center of those fragments. Use an area to extract the center. It's going to take a while, and here we go. We can give this to the center of this, turn this off, and as you can see here, we can also give a factor, so maybe 85%, 0 to 1 number. We can define it here. We can turn this off, and you can see the surface is emerging here. Okay, those grids. So what we can do is now again split the base surface with these curves. So we will have these borders and those windows. Again, we can search for split 2, and here we have this. Let's search for split. I think that it's a surface split, so searching it is a little bit hard. So surface split will give you this, but you can find this from intersection, physical, a more easier way. Okay, surface split. Again, let's use the loft surface, and we can use that scaled surfaces to split that surface into segments. So this is the way you can also use this. It's going to take a while because surface split is like the split command in Rhino, and here we go. We can just bake this, and you can see that we have this surface and those windows. So how can we just have those borders and windows? It's simple. You can use the list item tool and extract the first number. Mainly the biggest surface is going to be the list item 0, and then we can use the col index and give an index 0 to this. and it would delete the 0 and give the rest. So you can see this is going to be the window. I can bake this into layer 1 and bake this into layer 2, and here we go. We will have that pattern. But remember, if you want to work on the pattern, first of all, changing these numbers will going to make you a little bit slow because of this surface split or this surface split here. And what I'm going to do is to take it off from here, right click on this and disable this. Okay, let's just turn these two set of curves on. You can right click or middle click and turn this on. Okay, so now we can play with those numbers. Maybe we want to produce something like this. Okay, we want to produce something like this, and maybe we want to change the numbers of the patterns. We want to play with this. Okay, you can see that this is going to be another pattern here, but beware of these sections because the scale of this section is going to be some problems for the surface. So I'm going to give this 4 to have its complete pattern. Okay, and you can see this from top. Here it is. And now we can go and turn on this surface split. And here we go. Okay, so this is how you can use Grasshopper simply to produce these patterns by circles and rotating them. So you can see that it's going to take us some while because it's going to split that surface from those curves, then it's going to scale them and again split that surface with another scale. So it's going to be a little bit okay, slow for that. I'm going to wait to see the results. Okay, so after a while we will have this border, and this one we can just simply bake this into layer 1 and bake this into layer 2, and here we go. And we can simply use this and use the offset surface in Rhino to give it this a solid, and you can also flip this if the direction is not right. You can see it's going to be inwards, so I'm going to flip this to outwards. And I don't know if it's 1 is okay, so let's just do this. So this is going to give you a solid. And after doing that, you can use this in the render. So I'm going to show you. You can see this is, I'm always using the artistic one because you can see the difference easily. So this is how you can produce the patterns with circles and in Grasshopper. So let's just stop for a while. Okay, and here it is. This is the pattern, and this, you can see how easy and beautiful it is. Okay, you can also go into the rendered section. Let's just put the layers. This was a layer 2. I'm going to give this a simple blue material as something like a window and just put the transparency on that. Let's just see that. Okay, here it goes, and you can see that you can simply define this. You can also bring this a little bit up, so maybe this will be better. So maybe let's just see that something like this and revolving this. So remember, you can always play with that and have the results. So thank you for watching this Grasshopper tutorial and subscribing to our channel. Please put your comments below this video. It will help us and help us our channel to bring up more and more videos. And also thank you for liking us, subscribing, and hitting that bell notification button. And thank you for watching.